This is exam 1, question 4. It asks us to solve the integral of sine square root of x dx. So for this, our first step will be to do a u substitution for the square root of x, or in other words, x to the 1/2. Du then equals 1/2 times x, negative 1/2 because we do 1/2 minus 1 dx. Or in other words, 1 over 2 square root of x dx. And then this can be written as well as 2 square root of x du equals dx. Because of our u substitution, it is 2u du equals dx. And now we plug in our u substitutions. So we have the integral of sine u times 2u du. And because our 2 is a constant, we bring it out to the front and rewrite it as 2 integral of sine u times u du. Now, because it's multiplication, we use the product rule of integration, written as the integral of u dv equals uv minus the integral of v times du. For our u, we'll make it u, and for our dv, we'll make it sine of u. So u equals u, and the derivative being du. Our derivative equals sine u. And if we remember from our trig functions, the integral of sine theta is equal to negative cosine theta plus c. For now, we'll ignore the plus c until towards the end. So equals negative cosine u. And then we plug it into our formula. And we multiply u times v. Or in this case, u times negative cosine u minus the integral of negative cosine u times du. Then we'll rewrite it down here. And we end up with negative u cosine u plus, because of the negative here, integral of cosine u times du. And again, from our trig functions, we should know that the integral of cosine theta is equal to sine theta plus c. And then we rewrite it down here. Negative u times cosine u plus sine u. However, we're not done yet, because if we recall, this was not the whole function. There was also a times 2 here. We integrated everything else right here. However, we have not multiplied it by 2. So then it'll be 2 times everything here. And if we distribute the 2, it'll look like this. Negative 2 u times cosine u plus 2 sine u plus c. Because we didn't integrate with any bounds. However, we originally had a u substitution here, here, and here. So now we need to go back up here and plug in our u, which was originally the square root of x. And so we can rewrite this as negative 2 times the square root of x cosine times the square root of x plus 2 times sine square root of x plus c. And this is our final answer. Since we didn't integrate with any bounds, that is why we have the constant of c at the end.